Today we are diving into a fascinating comparison that shows how naval power is changing in the modern era. On one side, we have China's giant aircraft carriers, massive symbols of industrial strength, national ambition, and traditional sea dominance. On the other side, we have Israel's smart war web, a network-driven approach that connects sensors, weapons, intelligence, and decision-makers into one fast, adaptive system. These two models represent very different ideas about how future wars at sea might be fought. China's aircraft carriers are designed to project power far from its shores. They are not just ships, but floating airbases, capable of launching fighters, helicopters, and surveillance aircraft across wide ocean areas. For China, carriers symbolize its rise as a global power and its desire to protect sea lanes, assert territorial claims, and influence events beyond East Asia. Each carrier is a statement that China wants a navy capable of operating on the world stage. The scale of China's carriers is hard to ignore. These ships displace tens of thousands of tons, carry large air wings, and require thousands of crew members. They rely on escort ships, submarines, and supply vessels to form carrier strike groups. This creates a powerful concentration of force, but also a complex and expensive system that must be protected at all times. The carrier becomes both a sword and a shield. China's carrier program has evolved quickly. Starting with refurbished designs, China has moved toward domestically built carriers with improved flight decks, catapult systems, and more advanced aircraft. Each new carrier reflects lessons learned from earlier models and from studying other navies. This steady improvement shows long-term planning and massive investment in shipbuilding and training. Aircraft carriers excel at visible deterrence. When a carrier group enters a region, it sends a clear political and military message. Fighters launching from the deck can conduct air superiority, strike missions, and reconnaissance. In peacetime, carriers support diplomacy, disaster relief, and presence missions. In wartime, they offer sustained air operations without relying on foreign bases. However, carriers also face growing threats. Modern missiles, submarines, cyber attacks, and drones challenge the idea that a large ship can operate safely near hostile shores. Anti-ship ballistic missiles, long-range cruise missiles, and swarm tactics are designed specifically to target big, valuable platforms. This forces carrier operators to invest heavily in layered defenses and electronic warfare. This is where the contrast with Israel's approach becomes clear. Israel does not rely on giant carriers to project power. Instead, it focuses on integrating information across domains. The smart war web is about speed, connectivity, and precision rather than size. It links satellites, drones, radar, naval vessels, aircraft, cyber units, and ground forces into one shared picture of the battlefield. In Israel's model, information is the most important weapon. Sensors constantly feed data into command systems, where artificial intelligence and human analysts process it in real time. Targets are identified quickly, threats are prioritized, and the most suitable weapon is assigned automatically or semi-automatically. This reduces the time between detection and action to minutes or even seconds. At sea, this means smaller platforms can punch far above their weight. A corvette or patrol vessel connected to the war web can receive targeting data from drones or satellites and launch precision weapons without seeing the target directly. The ship becomes a node in a network rather than a standalone fighter. Survival depends on mobility, stealth, and information dominance. Israel's naval philosophy reflects its strategic environment. Surrounded by potential threats and operating in relatively confined waters, Israel prioritizes defense, early warning, and rapid response. Its ships are equipped with advanced sensors, missile defenses, and communication systems. They work closely with Air Force assets and intelligence agencies, blurring the line between services. The smart war web also emphasizes resilience. Instead of concentrating power in one massive platform, capability is distributed across many nodes. If one ship, drone, or sensor is destroyed, the network continues to function. This makes it harder for an enemy to deliver a decisive blow. The system adapts, reroutes information, and keeps fighting. When comparing these two approaches, it is important to understand that they are not mutually exclusive. China is also investing heavily in networks, sensors, and data integration. Israel, meanwhile, understands the value of visible deterrence and maritime presence. The difference lies in emphasis and scale rather than absolute capability. China's carriers are optimized for blue water operations. They are meant to operate across oceans, protect distant interests, and support long-range missions. This requires endurance, logistics, and the ability to sustain air operations for long periods. In such scenarios, large decks and extensive support systems make sense. Israel's war web is optimized for high-intensity, fast-moving conflicts. Decisions must be made quickly, often under missile threat. The goal is to detect first, strike first, and neutralize threats before they can cause damage. The Navy becomes part of a larger national defense system rather than an independent force. The future of naval power will likely combine elements of both models. Large platforms like carriers may still play a role, but their survival will depend on how well they are integrated into broader networks. A carrier that cannot see beyond its own sensors or react quickly to new threats becomes vulnerable. At the same time, networks without sufficient platforms to deliver sustained force may struggle in prolonged conflicts. Precision strikes are powerful, but wars also require endurance, presence, and the ability to control sea space over time. This suggests that balance, rather than extremes, will define successful navies. Technology is pushing navies toward greater connectivity. Artificial intelligence, big data, and autonomous systems are changing how decisions are made. Future naval battles may be decided less by the size of ships and more by the quality of information and speed of response. In this environment, Israel's smart war web offers valuable lessons. One key lesson is the importance of integration across domains. Naval power is no longer just about ships and submarines. Space assets, cyber capabilities, and air power are equally important. A navy that operates in isolation is at a disadvantage. The sea is now part of a larger, connected battlefield. Another lesson is adaptability. Israel's systems are designed to evolve rapidly. Software updates, modular designs, and flexible doctrines allow quick adjustments to new threats. This contrasts with the long construction timelines of large carriers, which can take years or decades to design and build. China faces this challenge as well. As it builds carriers, it must ensure they remain relevant in a fast-changing threat environment. This means investing not just in hulls and aircraft, but in electronic warfare, cyber defense, and network integration. A carrier that cannot operate within a smart war web becomes a liability. The human factor also matters. Operating a carrier requires extensive training and coordination among thousands of personnel. Managing a war web requires skilled analysts, operators, and commanders who can trust automated systems while maintaining human judgment. Both models place heavy demands on education and doctrine. Cost is another critical factor. Aircraft carriers are among the most expensive military assets ever built. They require constant maintenance, escorts, and logistical support. Smart networks also cost money, but they often offer better cost-effectiveness by upgrading software and sensors rather than building entirely new platforms. Smaller nations watching this comparison may find Israel's approach more realistic. Not every country can afford or justify building giant carriers. However, many can invest in sensors, drones, missiles, and data integration. This levels the playing field and allows regional powers to challenge larger navies. For major powers like China, carriers remain attractive because they serve political, diplomatic, and military roles. They symbolize national pride and technological achievement. They also allow sustained operations far from home. The challenge is ensuring they can survive and operate effectively in contested environments. Looking ahead, unmanned systems will play a larger role. Drones at sea, in the air, and underwater will expand the reach of sensors and weapons. These systems fit naturally into the war web concept. They can also support carriers by extending their awareness and defensive perimeter. Cyber warfare will also shape naval conflict. Networks are powerful but vulnerable. Protecting data links, command systems, and sensors from hacking or disruption is critical. Israel's experience in cyber defense gives it an advantage, while China is also investing heavily in this domain. The future naval battlefield may be less about dramatic ship-to-ship battles and more about invisible contests of information. Who sees first, who understands faster, and who acts smarter will likely win. In that sense, the smart war web may define the direction of naval warfare. Still, the image of giant carriers will not disappear overnight. They remain potent tools of influence and force projection. The real question is how they adapt. A carrier that becomes a central node in a smart war web, rather than a standalone platform, could remain highly relevant. In the end, China's giant aircraft carriers and Israel's smart war web represent two paths shaped by different needs, geographies, and ambitions. One emphasizes scale and presence, the other emphasizes intelligence and speed. The future of naval power will probably belong to those who can combine both effectively. As technology continues to evolve, navies around the world will study these models closely. The oceans may remain vast, but the battle space is shrinking in time and information. Adaptation, integration, and innovation will decide who controls the seas in the decades ahead.